Hey everyone. So today we are going to just do a recap of the nano degree this far. This is the 7th week. Um, so yeah, let's just get straight into it. So uh, after the kickoff meeting, or the kickoff week where everybody was introduced to the program and how it worked, they got their syllabus and study plan. Then after that webinar, then we had the week 1 webinar, which dealt with working with the shell. And it's really important to just reiterate that the sooner you get comfortable doing as much as possible in the shell, the better. Um, it's really important for nearly any project that you do of any size. You're just able to work much, much faster. Um, and yeah, I think if you speak to any developer that does this as a full-time job, or even a lot of people that do it on the side, I'm sure you won't really find any developer who is able to work with and build projects without working in the shell. It's important for so many reasons, but some of the more important one, or the most important ones, would be speed. It's just so much faster to do anything in the shell, which I know at the beginning seems very unintuitive because you can move so much faster with your mouse and you understand how to do so many things. But once you get your head around a lot of the different commands, it just becomes so much easier. So copying, pasting, moving through different folders, moving folders and individual files to different areas, batch processes, renaming, uh, piping, a whole bunch of different commands, writing scripts. It just all becomes orders of magnitude faster. And I guess the best way to just to realize this is to practice. So even if you don't have something super specific for this full stack nano degree, you could start writing scripts to make your daily tasks a lot easier. So I think Corey Schaefer has quite a few videos on this. One in particular I remember is where he just renames all of his music. I think it was him, but yeah, that's just something that's probably very useful to lots of people. Maybe not if you only stream music nowadays, but renaming any type of file is just super useful. So just practice um, writing scripts that do a bunch of things, and you'll see how useful it is to be working in the shell. It's also more effective. There's so many things that you can do which are close to impossible without working in the shell. Some of the examples would be configuring environments and servers. Uh, often you'll be troubleshooting or debugging. So you may want to step through different programs. Then running scripts we've discussed already. And then for testing, yeah, I guess this could fall under debugging. It's not the same, but they're kind of similar. But yeah, it's almost impossible to do this without the shell. And after that, we spoke about version control. So hopefully you guys are all using version control now, and you can just see how life-changing it is. It's so much easier to just keep track of your progress if you just push your changes up to hello, sorry. For some reason my headphones just died. So basically, if you have some version control software and an online repository, so I assume most of you are using GitHub, you'll see how much easier it is just to keep track of your progress, pushing all your changes up. Um, and it also just gives you so much freedom to try new things because you're not worried about breaking your code. You just revert to an earlier commit if you did do something and you make that the head. Um, it's also amazing for collaborating, working with a team, uh, creating pull requests, reviewing other people's pull requests, merging them into a document, um, dealing with merge conflicts. All of these tasks just make life as a software developer so much easier. And then later down the line, you'll probably get into continuous development and continuous integration, where it's just super important to always um, to to do as much automation as possible. Um, so you can focus on doing the more complex stuff, and uh, the mundane tasks can be automated. And this not only makes your life a whole lot easier in terms of the amount of manual things you have to do, but it also just um, reduces the amount of errors. When a computer does something, there's far less room for error than if a human does it. So um, that's one of the philosophies behind continuous integration and development, where every time you make a change, the changes can be tested if the tests are automated. Um, and this is done automatically before, merging into a branch, maybe a master branch or a test branch. And then there's some running that's done there of the application, and then that's pushed to production. And if that whole pipeline is automated, um, there's just far fewer opportunities for things to break. So before you can even get to that, you really have to have a strong grasp on version control systems. So yeah, hopefully you see the the benefit of that, and are slowly working towards becoming an expert at version control and working in the shell. So after that, we had the HTTP request and response cycle, um, and we stressed how important it is to really just understand um, how a HTTP request is created, and so basically the anatomy of one as well as of a response. Um, this is because even if, say, for example, in this full stack nanodegree, you're doing Flask, but I think a lot of people will move to Django, which um, may seem like it's not super important to understand the actual details of every request and response. But as soon as you start integrating APIs, um, which nearly every single web service does, then you'll see immediately that it's super important that you understand this backwards. So I guess the best way to actually just practice this is to build APIs. There's thousands of tutorials on YouTube on different APIs you can build. So yeah, we went through the requests, the three parts of the header, so the verb, and how those relate to CRUD operations. So um, then we looked at the request URI, and then obviously the HTTP version, which doesn't really change. We did the same for responses. We looked at the status and the response code. So examples, both requests and responses would be, so if you're making a request, you'd have possibly a GET request, maybe a POST request, maybe a PIT, and then the URI. So for example, if it was a POST request and it was a form that you filled in, the URI would be your application's address or location of the form that was being filled in. And then obviously 99% of the time, HTTP version 1.1. Then an example of a response would again be your HTTP version. Then say, for example, you made a request and it was successful. You would get a response back of 200 and a status of OK. Then just Another important point I touched on it is just to understand what um, REST is. So that's representational state transfer. Um, and essentially, this just is a protocol or a set of rules for how a server and a client would talk to each other. So essentially, what you need to um, have cemented in your mind is that there's never any how do you say it? Every single um, message that gets transferred is a complete message. So the state of your server never ever changes. Um, so this is super important. It's a massive topic, so I won't go into it, but it's super important to understand this, um, especially when you're building your application. That's how you'll know exactly what or how to design your application. Um, Probably you want it to be RESTful. Um, but as I mentioned earlier, if you're using Django, Django isn't really RESTful. Um, but then the funniest thing is that most people just will incorporate the Django REST framework into their Django application. So then it becomes RESTful anyway in the end. Okay, so after that, we had week 3, which was SQL, and then week 4 was the SQL project. So we went through entity relationship diagrams, how that's the kind of bedrock, how you begin an application by understanding, it's not the exact beginning, depending on exactly what you're doing, but you might go and do requirements analysis and requirements gathering and figure out exactly what your customer, whoever you're building your application for, wants. And from there, you may start designing the application, know what it should look like. And then from there, that's when you might start with your entity relationship diagram. That's when you get to the actual specifics of how the application will work, what your models are, what the relationships between the different models are. And that's dictated by the entity relationship diagram and the cardinality, which is the relationships between them. We then went into the different SQL commands. And they're relatively easy, but it's important to it's not a complicated syntax. It's rather intuitive, except it can catch you up if you just you know haven't practiced it. So the way I think of it is more like maybe something mundane, like setting up an IKEA piece of furniture. If it's something you do once off, you might do it pretty slowly, right? But if you read the instructions or the pictures on the instructions and you say assemble the same thing about 10 times, once you've done that, you no longer need the instructions. So there was no real complexity, but there's still some memorization that's involved. And I think that SQL is kind of like that. You just really need to memorize it. And once you do, you forget the actual SQL and you're just looking at um, the objects and the relationships between them and writing the SQL that allows you to get the most out of those relationships. So I suppose that's the best way to, that's how I see it. So where the trickiness can come in when you're new to it is that you may not know how to do some of the more complex queries. So for example, if you want to select some certain um, things from a range of tables depending on a range of criteria, that's when it may become complicated. And there's usually more than one way to do things. So that's when you have to really understand your views and your joins, your left joins, your left outer join, your right outer join, your inner joins, and know when's best to use which one. And the only way to do that is just by practice. It really doesn't help to sit and memorize. Because by doing it, it just gets solidified a lot faster than if you just arbitrarily memorizing what a join is and how you write the syntax for the join. Yeah, then we went through the project log analysis and why it's important. And then from there, 2 weeks ago we did the Flask framework, and we did something similar to with SQL, where um, instead of we went from our ERDs, and instead of going into SQL commands, we introduced an object relational mapper, which is SQL alchemy. So just keep in mind that this has nothing to do with Flask itself. It was just introduced at the same time, and it's a very useful um, library. Basically, well, there's a lot of different object relational mappers, but I think by far the most famous one is, or widely used one, would be SQL alchemy. And basically, SQL alchemy connects your Python application to your database. So it converts your Python code into SQL queries. And this is just fantastic so that you only have to worry about one language. It makes it so much easier. If that's Python, you don't have to worry about um, your queries, and it just makes for a project that's easier to read, easier to maintain and modify. So we went through that. And then we went through Flask development, how to build a basic application. And we did some comparisons, like showed the amount of code that you use if you were going to build an application without a framework, to do a bunch of different things. And then how many lines less. So like a quarter or a fifth of the amount of lines of code are required to write a Flask application than to write an application in Python without a framework. So essentially the framework just does a lot of the heavy lifting for you. So there's templating, there's, one line describing whether it's a get or a post request, um, as opposed to setting all of that up using Python, the Python standard library. Um, and then we also did a quick comparison with another framework, so Django. I think it's useful to just always compare them, because essentially if you're building full stack web applications and you use Python, I mean, there's no need to. You could use Bottle or Pyramid or a bunch of other applications, but essentially most jobs are going to require you to know either Flask or Python, or both. Sorry, Flask or Django, or both of them. So it's good to know when to use one and when to use the other. Maybe one important takeaway, just to get you going on your journey of developing opinions on which to use, would be to remember that I don't know if it's the official logo, but Django is like Django. They say batteries included. Batteries included. So essentially, with Django, you can, it takes a bit longer than Flask to set up, to get up and go and running. So Flask, you can have a working application in literally like 5 minutes or less. Whereas Django, it'll take you a lot longer. Or yeah, maybe half an hour, depending how good you are with it and what you want it to do. But the Django application will have a whole lot more functionality built into it, from its admin dashboard to the different views and the forms, and no importing of template engines or anything like that. No importing of object relational mapper, even though you can, use SQL alchemy instead. But yeah, that's what makes Django so much faster, or faster for building generic applications. But this quickly stops being an advantage if the application that you're building is very unique, in the one instance, because Django has a lot of boilerplate, whereas Flask is super, super lightweight, meaning that whatever you want to build it into, it can become, and whatever you don't want it to be, you don't have any heavy baggage. But then for API development, you just want endpoints. So maybe you just want to be doing certain requests to your database, and you just want to set up a backend that allows you to maybe JSONify that. So basically, just have some endpoints and information that's going to be retrieved from a range of different clients. So it might be a Android or an iPhone application, or it might be a large web app, or it might be another backend service that's requesting information from your application. And so you want the exact same data to be sent to all of these applications if they all are sending the same API, even if they may present it completely differently, the information. And that's why APIs are so important, the design of them. And then, yeah, if you have Django and that's all, it's not really going to help you. So you either have to learn the Django REST framework, which is great. I suggest doing that. Or just get really good at Flask as a starting point. And I think it's really cool that Udacity has chosen to go with Flask in the beginning before teaching Django. I think it makes you a lot less lazy. Um, yeah, and then we spoke about OAuth, or its second version, OAuth 2. Essentially, this is just third-party authentication and authorization. We discussed what authorization is and that it's allowing you to do checking what you are allowed to do, and this is completely different from authentication, which is checking that you are who you say you are. We went into why you would allow third parties to do this on your behalf, instead of as a application developer doing this yourself. And we said that it's just a whole lot of legwork and responsibility because of the security of your user's sensitive information, and it's far better to let a specialist or someone who's done this many times rather, and or is already storing your user's information. Let them, so don't duplicate the user's information. Just leave it with the third party that the user already trusts, and then just follow this workflow that allows you to piggyback onto that. It just is so much less work when building your own applications. So that would be the pros of it. The cons of it would be that your user may not use the main applications that that people use for OAuth, so Google or Facebook or Twitter or GitHub. So that would be a con. And then if the unthinkable happened and one of these large organizations did have a data breach, then even though it's not your fault, your users' information would be compromised, and you would have to take steps to secure your application. So those were the pros and cons. We then went through an explanation or a walkthrough of exactly how OAuth 2 works. And I think you guys should have been implementing it by now. So yeah, that's a quick overview of what we've done so far in the full stack nano degree, full stack web developer nano degree. And yeah, I hope you guys are still enjoying it. I'm enjoying mentoring it. It's a lot of fun, and there's such cool foundational concepts that you guys are learning, that you'll take through for the rest of your web development career. So yeah, if there's no questions, I hope the week goes well, and next week we'll get into the next section. Cool.